Synthetic analysis of a three-membering system. We will check out how three-membering system is established, and then we will analyze the different molecules involving a three-membering system for their retrosynthetic analysis. But before addressing a retrosynthetic analysis, we should first focus on how a three-membering system is established. Basically, the reaction in which a three-membering system is formed is known as insertion reaction. For example, we have one propene and it reacts with hydrogen peroxide in the presence of a base, and we get a system like this, which is known as epoxide. So this is a typical insertion reaction in which a three-membering system has established. Usually we require a different reagent which are needed for inserting a methylene group or heteroatom during the formation of a three-membering system. So these reagents involve for example, we could have diazoacetic esters. This is known as diazoacetic ester. Similarly, we could have sulfur ylides. Which is much the same like a phosphorus ylide. We could have diazomethane. We could have diazoketone. We can also use an important reagent such as diiodomethane, which is a reagent used in Siemens-Smith reaction in combination with zinc copper couple. Similarly, we can use halo form or halocarbenes such as this is halocarbene. So these are different reagents which can be used for insertion reaction in order to make a three-member ring system. We will check out this reagent so that we could understand how they could be applied for making a three-member ring system. As far as the diazoacetic ester is concerned, it is made from glyphene amino acid. For example, we have a glyphene amino acid. It is subjected to Fischer esterification in the presence of acid. and this species is ultimately subjected to diazotization reaction by treatment with nitrous acid. So we get N2CH CO2 ET if R is taken as ethyl group. So this is known as diazoacetic ester, which is used as inserting agent or as a reagent for introducing carbene to make a three-membering system. As far as sulfur LED is concerned, usually it is made from sulfides such as dimethyl sulfide that can act as a nucleophile, and it is reacted with methyl iodide in SN2 fashion, and we get Me3 plus. So when it is treated with a base, the proton can be extracted and we get a sulfur elite by this way. As far as diazoketone is concerned, it can simply be made from acid chloride, and they are treated with diazomethane. And when it is subjected to either light or silver iodide catalyst, we get a methylene moiety. So these are different reagents which can be used for making a three-membering system. Now we will apply this reagent for making a different ring system, and will observe different molecule involving three-membering system for their retrosynthetic analysis. For example, we have a system now. One reagent can be this, which can simply be treated with hydrogen peroxide for getting the product. As far as another method is concerned, it involves the carbene source of diazoacetic ester. Now let's check it how it can be utilized for making the base. For example, we have starting material which is treated with the base, and we get an enolate like this that react with this negative charge take over here while expelling chlorine atom from the molecule, and we get the product which was the target material at the start. So here we checked out how we utilize diazoacetic ester in making a three-member ring system. So this is known as a Dorson's reaction. In order to apply again this application, let's consider another molecule. This is a three-membrane system, and we are trying to subject it to retrosynthetic analysis. We break this bond, which form as a result of intramolecular Friedel-Cropf acylation reaction. A functional group interconversion. And finally, we get the product like so this is a retrosynthetic analysis of this compound, in which we have utilized diazoacetic ester in making the target material. For example, diazoacetic ester is first reacted with the aromatic compound bearing a vinyl group. Consider its synthetic analysis. This compound is reacted with let me put a star on it with diazoacetic ester for generating a compound like what we have sketched above. ET. This is subjected to basic reaction with NaOH, and then thionyl chloride, so that we could get acetic acid or carboxyl group at first instance, which is then treated with the thionyl chloride for getting acid chloride. So I will get the product like this, and this product is ultimately subjected to intramolecular Friedel-Cropf acylation for getting the target material. So these all are example of Dorson's reaction. This is known as Dorson's reaction. Even we can have a three-membering system without adjacent carbonyl group. For example, this is an epoxide which has no adjacent carbon atom and it can be subjected to retrosynthetic analysis. A ketone and a carbene, and the carbene act as a nucleophile that can be obtained from a sulfur elite. For example, if the ketone or aldehyde bearing a carbonyl group is treated with a sulfur elite, so we can easily get this target material. So here we can use the application of sulfur elite for getting the target material. As we have studied earlier, an example of ephemeral drug, salbutamol, which has a structure like and tertiary butyl group, and this tertiary butyl group is very important because it make the drug longer lasting. This salbutamol molecule is closely related to adrenaline, which is a flight or fight hormone. Adrenaline has a structure like so this is adrenaline. Now earlier we have studied about salbutamol retrosynthetic analysis. Now we will subject the molecule into different conditions so that we could utilize the application of a three-membering system. Let me disconnect this bond. OH an epoxide ring plus a tertiary butylamine. This is a tertiary butylamine. This can further be subjected to CHOR formyl group, and at last we can get the molecule like this, which is available. So this is retrosynthetic analysis of salbutamol, in which we have noted the application of epoxide ring. Now let's focus on its synthetic analysis. Synthetic analysis of salbutamol. This product is reacted with formaldehyde so that we could get a benzyl hydroxyl group. Then it is treated with acetone in acidic condition so that we could protect the 2-hydroxyl group, and this protection is important before we make any reaction on formyl group. Now we add sulfur elite for transforming the molecule into an epoxide, and finally this epoxide is treated with tertiary-butylamine and acidic hydrolysis for getting to the target material. So this is how we can establish the synthesis of sal-butamol. As far as cyclopropyl ketone are concerned, such as this molecule, so we can synthesize the 3-membrane system with application of diazomethane. For example, we could have its simple retrosynthetic analysis. This is known as inserting reagent. Diazoketone species which is used for introducing a methylene group into a molecule for getting the target material. Similarly, we can also use diiodomethane as we have used in Siemens-Smith reaction in combination with the zinc-copper couple. Siemens-Smith reaction is highly stereoselective. For example, if we have a starting alkene as a trans, and so product will be trans, and if starting material is cis, then the product will be cis. Besides diiodomethane, we can use halocorbeams. For example, we have chloroform as a starting material. When it is treated with a base, we get the product which ultimately expel the chlorine group, and we get a methylene moiety which is required for insertion reaction and we get product like. So this is the application of hello carbene that can be used in retrosynthetic analysis of a compound. So the 2-bromine atom could be replaced by bromocarbene, and we get the species like this. Here we have protected acetal, that can be obtained from this species. So if we consider its synthetic analysis, take a start from treating it with a base and 2 molecules of methyl iodide, alkylation take place, and we get which is reduced by lithium aluminum hydride, and we get species like this. This is ultimately reacted with aldehyde for generating species number 1, as I have noted it as number 1, and this is ultimately reacted with bromoform in a basic condition, so that it generates bromocarbene and we get to the target material. So I hope that today's session would help a lot in making your concept about 3-member ring system, how it is generated, what are reagents required for making a 3-member ring system, and a retrosynthetic analysis of those molecules which contain a 3-member ring system. Thank you for watching the session.